Hi guys, and welcome back. So today we're going to continue to solve more exponential equations, but we're going to focus on the case where both the left side and right side cannot easily be written in terms of the same base. But wouldn't it be nice if we quickly review the problem where we can fix it so the left and right side can be written in terms of the same base. So let me just go ahead and write BP, which is my made up abbreviation for bonus problem. So let's just say we are asked to solve, where am I? We have 5 raised to the 2x equals 25. Okay, so the question is, when it comes to solving exponential equations, I'm always going to ask myself this question: can I easily fix it so both the left and right side are written in terms of the same base? Well, last time I checked, 25 is the power of 5, so I can write 25 in terms of base 5. So in this case, we can easily fix it so both the left side and right side are written in terms of base 5. Sorry. So the left side is already in terms of base 5. The right side, it's an easy fix. Okay, so we have 5 to the 2x is equal to 25. If we write it in terms of base 5, we're going to write it as 5 squared. Fantastic. At this point, what are we going to do? So the property of exponential equations, remember from like many moons ago, the property of exponential equations says this: if the bases are the same, if the bases are equal, then there's no way around it, then the powers have to be equal. Okay, if the bases are equal, then the powers have to be equal. So we're going to set the left exponent equal to the right exponent. Handle it however you can. Okay, to isolate the x, to get rid of the times 2, let's go ahead, divide both sides by 2, and that will leave us with x equals 1. Fantastic. Now let's go ahead and look at our actual planned problem. Okay, we have the directions. I forget to read them. Solve each equation, give answer in exact form, so that's the exact answer, and then round, you can't see it, and then round all irrational solutions to 4 decimal places. So an irrational number, that, remember, that's just code for a number that cannot be written as a quotient of 2 integers. That's like a lot. I will illustrate that in a bit. Okay, so problem A. So we have the variable in the exponent area, so exponential equation. How do we solve exponential equations? So I'm going to ask myself, can I easily fix it so both the left side and right side can be written in terms of the same base? On the left side, we got a 13. On the right side, we got a 4. Unless my eyes fail me, I don't think we can easily fix it so both the left side and right side are written in terms of the same base. So what are we going to do? And we're going to take the logarithm of each side. Now the question is, when we take the logarithm of each side, should we use logarithm base 13, logarithm base 4? It doesn't really matter, okay? But check it out. My calculator and your scientific calculator doesn't have a logarithm base 13 key, doesn't have a logarithm base 4 key, and I'm trying to avoid the change of base rules, so I want to work with what we have. When we take the logarithm of each side, we can either choose base 10 or base e. Base 10, the common logarithm, base e, the natural log. It's really a personal choice. I'm so used to punching in log, so we're gonna take logarithms of each side, base 10. Okay. So when do we take the logarithm of each side? We take the logarithm of each side when we cannot easily fix it so the left and right side are written in terms of the same base. Okay, so let's take the logarithm of the left side, logarithm of the right side. Okay, again, when you take logs of each side, when you cannot easily fix it so the left and right side are written in terms of the same base. Okay, what base did we take for the logarithm? Since we didn't highlight the base, then it's base 10. Okay, now what are we gonna do? We're gonna look in this case at the left side where the variable is, and we're gonna use the power rule for logarithm. So let me remind myself. Okay, the power rule for logarithm says this: if I have the logarithm base something of x to the r power, okay, you don't really have to memorize like the variables, it's more of an understanding. Okay, so if the argument is being raised to some power, how can we tone it down? Okay, the power rule of logarithms pretty much says this: we're going to take that exponent, whatever that is, and then multiply it by the leftover logarithm. So in this case, the leftover logarithm is log base b of x. Okay, so that's how we're going to tone it down. Let's use the power rule for logarithms to bring the exponent down, and that will be multiplied by the leftover logarithm. Okay, for me, sometimes the lowercase l with tired eyes, I confuse them with the digit 1, so I'm going to switch them to uppercase. Okay, so when we apply the power rule of logarithms, we bring the exponent down and then multiply it by the leftover logarithm, which is log 13, and in this case equals the right side. Okay, so we have log 4. Okay, now at this point it's just a regular linear equation or degree 1 equation. So now the question is, how are we going to isolate that x? I want to know, what am I going to do to get rid of the times log 13? To get rid of a times something, we do division. So let's go ahead, divide both sides by log 13. Divide both sides by log 13. So when we do quotient of log 13 and itself will give us 1, or they cancel out. And yeah, you cannot see that. Okay, remind me not to use highlighters again. Okay, quotient of log 13 and itself will give us 1, or they cancel out, and that will give us, with x equals exactly log of 4 over log of 13. Someone said, can we keep the lowercase l's? Yeah, you know what? Go for it. Okay. When it comes to solving equations, we always want the exact answer. So that is the exact answer. Okay, but it would be nice if we have a sense of what this simplifies to. So for that reason, the directions read, give me the exact answer and then round all irrational solutions to 4 decimal places. What is an irrational number? A straight definition of an irrational number is a number that cannot be written as a quotient of 2 integers. In English, an irrational number is just code for a number that cannot be written as a fraction, like our normal fractions, like a half, 2/3, not something like this. Okay, so we want the answer in exact form, checked, but now we're gonna go ahead, have to round it. Okay, so let's go ahead, punch it in. So go ahead, bust out your calculator. It would be nice if I can turn it on. So we have logarithm of 4. Let's go ahead, close the argument. So we're going to put that close parentheses, and then we're going to hit the division button, and then we're going to divide it by log 13. So we hit log again. Argument is 13. Go ahead, close the argument. So we have log of 4 over log of 13. If you think you maybe punched it in wrong, then you can use the side arrows to confirm that you entered it correctly. Okay, so we're going to go ahead, hit enter, and we want to round this to 4 decimal places. So it's hard for me to round, so I'm going to put 5 digits. So we have 0.54047. 1, 2, 3, 4, and the 5th one to help me round. Okay, we locate our rounding digit, which is a digit in the 4th decimal place. We look right next door, and looks like we are gonna round up. Okay, so we have x is about, we round up, all the digits before it will stay put, and then we will ignore the remaining decimal digits. So the question is, what do we submit for credit? For this problem, we will be submitting 2 separate items. The first one is the exact answer, and then the second one will be the decimal approximation to 4 decimal places. Okay guys, so I have planned a total of 1, 2, 3, 4 problems. That is our first problem. Let's go ahead, knock out number 2. Problem B, we have, we already did that one. We have 3 raised to the negative x plus 5 power equals 8. Okay, yeah, you can now see that. Okay, 3 raised to the negative x plus 5 power equals 8. So we got a variable in the exponent area, so exponential equation. So I'm gonna ask myself this: can I easily fix it so the left and right side are written in terms of the same base? For this problem, the answer is no. 3 is a prime number, so it's going to be 3 or bust, and 8 is not a power of 3. When we cannot easily fix it so the left and right side are written in terms of the same base, then we're going to take the logarithm of each side. Should we take the logarithm of base 3, take the logarithm of base 8, it's fine. You can do whatever you want, but we don't have a log base 3 key here. We don't have a log base 8 key here. So the recommendation is to stick with the common logarithm or the natural logarithm. You'll get the same answer, I promise. We'll just go with the common logarithm. Okay, so take the logarithm of each side, base 10, logarithm of the left, logarithm of the right. Remember, when the base of the log is 10, there's no need to write it. It's understood that if it's not there, then it's base 10. What are we gonna do? We're gonna go ahead, use the, once again, where am I? We're gonna go ahead, use the power rule of logarithms to bring the exponent down. Okay, let's go ahead, use the power rule of logarithms to bring the exponent down, and that will leave us with the exponent of negative x plus 5 times the leftover logarithm, okay, times the log of 3. Now I understand myself. I know that I meant to write exponent times log 3, but check it out, the world cannot read my mind. Okay, the world only sees that I'm not multiplying the entire negative x plus 5 by log 3. I'm looking at what's before and after the raised dot. The only thing that's before the raised dot is the 5, and the things after it is the log 3. So what I want to get at, that the world sees that you're only multiplying the log 3 by 5. Maybe I make this a bigger deal than needed, but you know, the little things quickly add up, so be careful with your notation. Let's go ahead and wrap up this two-term expression. Okay, so we bring the exponent down and then multiply it by the leftover log, namely log 3 equals the right side, a log 8. Okay, what are we gonna do? It's really a personal choice because we all think a little bit different. So our solutions may differ, but signs cancel and we'll get the same answer. For me, I'm in the habit of clearing the grouping symbol, so let's go ahead and distribute. Log 3 times the first thing that we see will give us negative x log 3. Okay, one product down, one more to go. Log 3 times 5 is just log 3 times 5, but we'll put the 5 before. 5 times log 3 equals log 8. Okay, fantastic. So let's go ahead and work our magic to isolate the variable term. So if you're not with the x, you gotta go. To undo an addition, let's go ahead subtract. So we'll put minus 5 log 3 to both sides. And that will leave us with negative x log 3 is equal to whatever you want on the right. You can put log 8 first or the minus 5 log 3 first. It's a personal choice. For me, it's easier to start on a positive note, so I'm going to put the log 8 first. So that will give us log 8 minus 5 log 3. Fantastic. So we've isolated the variable term, but now we want to isolate the variable itself. To get rid of the times log 3, we're going to go ahead divide both sides by log 3. But that will leave us with a negative sign, so let's just go ahead divide both sides by negative log 3. After we divide both sides by a negative, quotient of two negative things will give us a positive thing, and the quotient of log 3 in itself will give us 1. So that will leave us with the x isolated, and x equals exactly log 8 minus 5 log 3 all over negative log 3. Okay. Now, if you took a slightly different approach to solving the equation, the expression will look a little bit different, but I promise that if we didn't make an algebra mistake, they will simplify to the same exact thing. So that is the exact answer. The directions specified to give the answer an exact form, and then round all irrational solutions to 4 decimal places. This is a fraction, but it's not your typical fraction. So let's go ahead, punch it in. Okay, we have the numerator divided by negative log 3. I'm gonna warn you, because we have more than one term in the numerator, we're gonna have to wrap it up. Okay, let's go ahead, bust out our fancy calculator. Where am I? Put parentheses, open the numerator, log 8. So here's our log button. Okay, it opens up the argument, logarithm of 8. Close the argument. minus 5 times log 3, 5 log 3. We're going to close that second argument, but remember we put an open parenthesis, so let's go ahead, close the numerator, and then we're going to hit divided by. I don't know if we need a parenthesis for the denominator because there's a one term only, but I'm not a risk taker, so I'm going to wrap up the denominator. So open parenthesis, negative sign, logarithm of 3. The first close parenthesis will be to close the argument, and the second close parenthesis will be to close the denominator. Okay, we are asked to round this to 4 decimal places. I can't see it from there. Okay, so I'm going to go ahead put 4 decimal digits with the bonus one to help me round. So we have that x is about 3.1072, the extra one for added kicks. What if you're really good at rounding? Then you can go straight to the approximation, but I'm not good at rounding, so I always put an extra one for fun. Okay, the digit in the 2 is our rounding digit. We look right next door, and in this case we're gonna have to round down, so we'll stay put with the 2. All the digits before it will stay the same, and the digits the decimal digits that are remain will be ignored. Okay, so we are asked to give the answer in exact form, and then also round it to 4 decimal places. Okay, fantastic. So I say I owe you, I say we're doing 4 problems. That's our second one. Yeah, we'll put them to Alright guys, so let's go ahead and do this. I was having a little internal dilemma if I should put this problem in this video or put it in another video, but as you can see it's going with this one, so let's do this. So we have an equation. The variable is in the exponent area, so we have an exponential equation. So I'm going to ask myself this question: can I easily fix it so both the left side and right side are written in terms of the same base? And in this case the answer is no. Okay, so when that is the case, we are going to go ahead take the logarithm of each side. Remember, work with what you have. Take the logarithm base 10 or base e. It's a personal choice. If you want to take base 100 or base 5, go for it. It's your grade. So let's go ahead, take the log of each side. We'll choose base 10. So we have log of the left side equals logarithm of the right side. Let's go ahead, use the power rule for logarithms to bring that exponent down. Okay, so when we do, that will give us, that will give us exponent time, I don't know how to copy my work. That will give us exponent times the leftover logarithm. Okay, exponent times the leftover logarithm, which is logarithm of 100, and that equals the right side. Okay, at this point I was going to go ahead, distribute the log 100, but I think I can simplify this by hand. Let me go ahead, highlight the base of the logarithm. The base of the logarithm is 10. So then I'm like, what does log base 10 of 100 simplify to? You could punch it into your calculator, but I think we could do it by hand. Remember, a log is just an exponent. So I'm like, base to what power will give us the argument of 100? So I'm like, 10 to what power will give us 100? And I'm like, okay, 10 to the second power is 100. So in this case, the logarithm of 100 simplifies to 2. Okay, if you're having a moment, punch it in, put log of 100, and it gives you 2. Okay, so that will leave us with 2 multiplied by 4x minus 3 equals log of 5. Cool. So let's go ahead, clear the grouping symbols, and then make the call of how are we going to solve it. When we distribute the 2 times 4x will give us 8x. 2 times negative 3 will give us negative 6, and that will give us logarithm of 5. Go ahead, work your magic to isolate the variable term. If you're not with the x, you gotta go to undo a subtraction. Let's go ahead, add to both sides. So we're gonna go ahead, add 6 to both sides, and that will leave us with 8x is equal to whatever you want on the right. You can put log 5 plus 6 or 6 plus log 5. It's a personal choice. I will put the integer term first, so that will give us 6 plus log 5. Work your magic. Do what you gotta do to isolate the x. To get rid of the times 8, let's go ahead divide both sides by 8. And that will leave us with x is equal to whatever we see on the right. 6 plus log 5. 6 plus logarithm 5 over 8. That is the exact answer. Bear in mind what are the directions. Give your answer in exact form, so that's the exact answer. And then round all irrational solutions to 4 decimal place. In this case, remember, an irrational number is a number that cannot be written as a quotient of 2 integers. In English, it's code for a number that's not like a regular fraction. So we want to have a sense of what this is. So let's go ahead, punch it in, round it to 4 decimal places, and then we're almost out. So we have more than one term in the numerator, so we're going to have to definitely wrap it up. So we're going to put an open parentheses to open up the numerator. 6 plus logarithm of 5. So we hit the log button. 5. First parenthesis, close parenthesis. Sorry, is to close the argument. This is what happens when you try to say so many things at once. I need water. All right. So we're going to close the argument, and then we got to close the numerator, and then we're going to divide it by 8. So you can go straight to answer, but you know my speech. I'm going to put the 4 required decimal digits, and then I'll put the bonus one to help me round. So we have 0.8373, and the 5th one to help us round. We identify the rounding digit, we look right next door, and in this case we will be rounding up. Let's add 1 to our digit. Anything before it will stay put, but the rest of the decimal digits get ignored. So we have the exact answer and we have the approximation. Cool, we could end it right here, but wouldn't it be nice if we did a 4th and final one? Yeah, I know you want that one too. Okay, problem D, and then we're out. So we have 27 raised to the 3x plus 5 is equal to 1 over 81. Okay, so we're like, okay, where's the exponent? Sorry, where is the variable located? So in this case, the variable is once again located in the exponent area. So we have an exponential equation. Now I'm going to ask myself, how am I going to solve it? When it comes to solving exponential equations, the first thing we want to ask ourselves is this: can we easily fix it so the left and right side are written in terms of the same base? In this case, I think we can. 27, last time I checked, is a power of 3. 81 is in the denominator, no big deal. 81 is also a power of 3. So in this case, we don't have to go straight to take the logarithm of each side like we did in our earlier problems. Okay, so let's fix it so the left and right side are written in terms of the same base, and in this case it's base 3. Okay, so this is a problem similar to one that we did in one of our earlier videos, but it's no big deal if we do a review right here. Okay, 27, to write it as in terms of base 3 or a power of 3, last time I checked, 27 is the same as 3 to the 3rd power. What is going on with that 27? Well, it looks like it's being raised to the 3x plus 5 power equals 1 over 81, but we want to write 81 in terms of base 3 or a power of 3. When you prime factor the 81 with the factor trees, that will give us 3 to the 4th power. So we got a 3 on the left, 3 on the right, but it's not quite base 3. On the left side, let's go ahead and use the power rule. And if you need a gentle reminder, power rule for exponents. So the power rule for exponents says this: if you got a factor and you're raising it to some power, how are you going to handle it? You're going to keep the base and multiply the exponents. Cool. So let's go ahead and apply the power rule for the exponents. We got this 3 cubed raised to the 3x plus 5 power rule. You're going to keep the base and multiply the exponent. So that will give us 3 times 3x plus 5 equals, we got a 3 on the right side, but it's not where we want it. We want on the right side, we want 3 to some power. Okay, we don't want like 1 over 3 to some power. So we're going to use the negative exponent rule for exponents in reverse. Let's go ahead, move this 3 to the 4th power to the other side of the fraction bar. And when we do, we're going to switch out that exponent. Okay, and then that's being multiplied by 1, but that will give us the same thing. At this point, we're going to apply the property of equality for exponential equations. So that property for exponential equations says this: if the bases are equal, then there's no way around it, then the powers have to be equal. If the bases are equal, then the powers have to be equal. So the left exponent has to equal the right exponent. You take your time, admire or look at your new equation, and then focus your energy on solving this one. Let's go ahead, distribute that 3. When we do, that will give us 9x plus 15 equals negative 4. Okay, so we have a regular linear equation, so let's do what we gotta do. First goal is to isolate that variable term. To undo the addition by 15, let's go ahead, subtract 15 from both sides, and that will leave us with 9x is equal to negative 19. Okay, to finish it off, to get rid of the times 9, let's go ahead, divide both sides by 9, and that will give us x equals negative 19/9. Okay, now someone asks, oh, I know we're done, but should we like punch it in our calculator? You know what, that's really a personal choice. Okay, the directions read: give your answer in exact form and then round all irrational answers to 4 decimal places. An irrational number is a number that cannot be written as a quotient of 2 integers. In English, it's a number that cannot be written like as a regular fraction. In this case, our answer is exact. It is a rational number. Okay, it's a fraction, so we don't have to punch it into the calculator. Okay guys, so I promised you 4 problems. That was our 4th and final problem. Until next time, gracias.